Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's Algebra 1 class. Today we will be wrapping up the year and radicals with learning how to solve radical equations. The good news is that it's very similar to solving regular equations. The bad news, it's not really bad news, but it's realistic. You have to know how to factor. You have to remember the quadratic formula. Okay? And you have to test these solutions to make sure that none of them are extraneous. So this is easy. It is a little bit involved, though. I'm not going to lie to you. There are steps that you must follow. I'm not going to lie to you. But I know in my heart that you can do this because it's everything that we've learned kind of just put together. So I believe in you. Let's have a positive attitude and let's just knock it out. A radical equation, my friends, which is what we're talking about today, is an equation that has at least one variable inside of a radical. The variable must be inside a radical for it to be categorized as a radical equation. If, of course, you know this, if the radical has an index of 2, that means that it's blank, okay? The index is blank. That means the equation is a square root equation. Let's assume that all radicals represent real numbers. So remember, guys, if it's just like this, that's a square root equation. If I have a third root, okay, that's a 3 as the index, that's called a cubed root. If I have a 4 as an index, that's called a fourth root. If I have a 5 as an index, that's called a fifth root, etc., etc., etc. So today we're going to learn how to solve any type of radical equation. Now, these steps should remind you of solving multi-step equations. The goal of any equation, doesn't matter if it's just a simple baby linear equation or a quadratic equation or a radical equation. The goal is to isolate the variable. Get the variable all by itself. And please remember that I want to solve for x over 1. I don't want to solve for negative x or 3x or 5 over x or x plus 7. I want to solve for just x alone in the numerator and positive. Procedure for multi-step equations. Let's just remind you. First, complete any distributive property first. So if you have a distributive property, go ahead and multiply it out. Number 2, combine like terms on both sides of the equation, if applicable. 3, move all the variables to one side. That means you want to get all the variables together on one side. In this particular case, we're dealing with variables that are in square roots. So why don't we go ahead and alter this. Move all radicals to one side. Undo addition and or subtraction, undo multiplication and or division, and last but not least, after you're done with all of those steps, you're going to be left with a radical when you're dealing with radical equations. To undo a square root, my friends, you raise it to a power of 2. You undo an exponent of 2 with a square root, and you undo a square root with raising it to a power of 2. Let's think about this. When I have a square root of x, if I go ahead and square it, the power of 2 cancels out the square root. If I have an x squared, and I take the square root of x squared, the radical and the power of 2 cancel. So what does that tell you for any radical? If I have an nth root radical, I can get rid of the radical by raising it to the power of the index. Okay? When I raise any radical to the power of its index, the radical and the power cancel. So if I want to get x alone here, the cube root of x, I'm going to cube it, and then that would equal x. If I have the fifth root of 2x, and I want to get that out of there, I go ahead and raise it to the 5th power. That radical cancels out with that exponent. So in order to get rid of any radical with an nth root, doesn't matter what the n is, 2, 3, 5, 19, 5 million. In order to get rid of a radical, simply raise both sides of the equation to the power that is equal to the index. You guys with me here? Okay. So let's move on. When solving radical equations, it is very important, my friends, to check your answers for what's called extraneous solutions. We've talked about this before, but I'm going to go ahead and talk to you about it again. Remember, we talked about this with absolute values. Extraneous solutions are solutions which do not work when plugged back into the equation. So you're going to get an answer. You're going to get x equals whatever, 7. When you plug that x equals 7 back into the original equation, if it does not work, then you have to label it as extraneous. Okay? So let's get to work. That was all the back work, the background. Now let's just do it. I want to solve for x. So I got to get the radical here by itself. So I'm going to subtract 8 to both sides. Square root of x equals -6. What am I doing? How do I get rid of a radical? A square root? Square root, I square it. If it was a cube root, I'd cube it. The radical, or the square root and the power of 2 cancel. So x equals 36. Most people are going to say, okay, I'm done, bye-bye. You would get this wrong. When you go ahead and check this, my friends, you plug it back in. Square root of 36 plus 8 has to equal 2. Well, what's the square root of 36? Does 6 plus 8 equal 2? So this here is an extraneous solution. Please, my friends, you have to check every single answer, every single time. You have to. Unfortunately, there's no choice. Sir, what does it matter if it's not a perfect square? You still plug it into the x. It does not have to be a perfect square, sir. Thank you, sir. So here I got a two-step equation. So I'm going to add 8 to both sides. 3 square root of x equals 15. Divide by 3. Square root of x equals 5. Why did I put square root of 5? Sorry. Square root of x equals 5. How do I get that x alone? Square both sides. Very good. Whatever you do to one side of the equation must be done to the other side of the equation. So when I raise the square root to a power of 2, they cancel. So x equals 25. Let's check it. If we check it, we got 3 times the square root of 25, which is 5, minus 8. Does that equal 7? 15 minus 8? Yes. So that is a solution. I'm golden. So everyone with me so far? You promise? Awesome. Thank you. Okay, next. I want to get this radical, this square root alone. How do I do that? I add 5 because I undo subtraction with addition. So I've got the square root of 4x plus 1 equals 5. How do I get rid of this square root? Excellent. Square it. Square root cancel the power of 2. I got 4x plus 1 equals 25. Subtract 1. 4x equals 24. Divide by 4. X equals 6. I got to test it though. So I have the square root here of 24 plus 1, which is 25, minus 5. Does that equal 0? Oh yeah. Because square root of 25 is 5. 5 minus 5 is 0. So it works. It works. Letter D, what do I do first, y'all? Subtract 3 to both sides. Excelente. So I've got square root of 2x minus 3 equals 5. How do I get rid of that radical? I get rid of a square root by squaring. This square root gets canceled out with that power. So 2x minus 3 equals 25. Add 3 to both sides. 2x equals 28. Divide by 2. X equals 14. Let's see if it works. I've got 3 plus 2 times 14 is 28. Minus 3 is 25. Does 3 plus the square root of 25 equal 8? Yes, because the square root of 25 is 5. 3 plus 5 is 8. So that works. That is a solution. You guys with me? Okay. Here, I want to get rid of this square root. How do I do that, y'all? Square it. Very good. Now here, pay attention to what's happening here. This is 3x minus 10. Wait a second. How do I factor a trinomial? Oh, I gave it away. How do I solve this trinomial? Okay, but before I factor it, what do I got to do? I got to put it into standard form. So I'm going to subtract 3x and add 10. So I got x squared minus 3x plus 10 equals 0. Always try to factor it first. What times what is 10, but when added together is negative 3? Negative 5 and 2 will not work because negative 5 times 2 is negative 10, not positive 10. No, plus 5 negative 2 won't work either because 5 times negative 2 is not positive 10. Negative 5 times a negative 2 will work, but negative 5 minus 2 is not negative 3. It's negative 7. Very good. It's not no solution, bless you. If it's not factorable, though, what formula can we use to solve any quadratic? Quadratic formula. So negative b plus or minus square root of b squared minus 4 times a times c over 2a, which equals 3 plus or minus, wait a second, this is negative 31. What do we know when the radical inside is negative? No solution, and you're done. But guys, just because it's not factorable, very good, thank you, does not mean that it's no solution. You have to try to factor it, and if you can't factor it, you have to put it into the quadratic formula. And then from there, you will be able to tell if it's no solution, or you will actually solve for the solutions. Next, I'm going to get rid of the square root of 2 by squaring both sides. X squared equals 2x plus 48. Subtract 2x, subtract 48 to both sides, so that I can get a quadratic formula here, a quadratic equation. I'm going to always try to factor it, always. It's just the way I do it. What times what, if anything, is negative 48, but when added together is negative 2? Positive 6 and negative 8. Okay, very good. Because 6 times negative 8 is negative 48, and 6 minus 8 is negative 2. Now you must use the zero product property and set each of these equal to 0. So x will equal negative 6 and positive 8. Now, I do have to test this. It's just the way it goes. So when I check it, let's first check for the negative 6. Negative times a negative 6 is 6. Does that equal square root of 12 plus 48? That would be square root of 60, right? Is square root of 60 equal to 6? So that's extraneous, guys. Sorry. Now let's check the 8. Negative 8. Does that equal 2 times 6 times 8 is 16. 16 plus 48 is 64. Does negative 8 equal 8? No. So unfortunately, guys, both of those are extraneous. So as you can see, there's no way to really just look at the problem and know if it's extraneous, my brothers and sisters out there in the internet world. You have to check it. Now, like always, I love word problems. Let me show you how easy it is when you just read and evaluate and just plug things in. The time it takes in seconds, T, for a pendulum of a clock to complete one full swing is represented by T, which is time, equals 2 times the square root of L divided by 3.3, where L is the length of the pendulum in feet. Okay, if the pendulum of a clock completes a full swing in 6 seconds, what is the length L of the pendulum? My friends, literally just plug it in and solve. So T is time, so 6 equals 2 times the square root of L over 3.3. I'm going to divide by 2 to both sides, giving me 3 equals the square root of L over 3.3. How do I get rid of this square root? You square it. 9 equals L over 3.3. How do I solve for L? By multiplying 3.3 to both sides. That's going to give me 29.7 feet equals L. It looked ugly, but it was actually quite simple. Don't be afraid of this. You guys have been taught skills to solve just about any word problems. Believe in yourself because I believe in you. Okay? But you gotta practice. Is everyone with me so far? Yes? Okay, give me 1 second. And no, yes, it's not extraneous. It does work. I'm not gonna do it right now. Well, I could. Yes, I can. Okay, 6 equals 2 times the square root of 29.7 over 3.3. Isn't 29.7 divided by 3.3 9? What's the square root of 9? What's 3 times 2? Does 6 equal 6? Bingo. We're golden. Does that make sense, y'all? Okay. Last but not least. Okay. I'm going to start at the bottom of these because I want to make sure that we get the hardest part, okay? So I'm gonna do C and D, and then I'll do A and B. Nothing new here, except you're gonna have to use some old knowledge. You're gonna have to use your skills, which I know you have. So first of all, the radical's by itself on one side, so I'm gonna square both sides. That's y plus 10. Now, most people do not write this down. Most people do this. Oh, that's y squared plus 4. And that is completely wrong. Y minus 2 squared, when you square a polynomial, that's y minus 2 times y minus 2, guys. Hope you remember that. So y times y is y squared. Y times negative 2 is negative 2y. Negative 2 times y is negative 2y. Negative 2 times negative 2 is positive 4. So now I have y plus 10 equals y squared minus 4y plus 4. Subtract the y, subtract the 10. 0 equals y squared minus 5y minus 6. Always try to factor. What times what, if anything, is negative 6, but when added together is negative 5? Negative 6 and positive 1. Very good. Now you said each of these equal to 0, so y must equal 6 or negative 1. Now let's check it. Always got to check it. Let's first check 6. 6 plus 10, that's square root of 16. Does that equal 6 minus 2? Let's see. Square root of 16 is 4. 6 minus 2 is 4. Yes, 6 works. Let's check the negative 1, guys. Negative 1 plus 10 is square root of 9. And negative 1 minus 2. So does 3 equal negative 3? No. So this guy is extraneous. That's the hardest type you're going to have, where you have to square a polynomial. That's the hardest type, in my opinion. The rest are Mickey Mouse. So let's go ahead and show you how Mickey Mouse they are. Let's just knock these out. So I've got the square root of 7x minus 3 equals 2. Square both sides. 7x minus 3 equals 4. Add the 3 to both sides. 7x equals 7 divided by 7. X equals 1. Let's check it. 7 times 1 is 7, minus 3 is 4. Square root of 4 minus 2, does that equal 0? Oh yeah, yes it does. Square root of 4 is 2. 2 minus 2 is 0, so it works. That is your solution. Does that make sense, gentlemen? Okay. Let's look at A here. Subtract 5 to both sides. Negative 3 equals square root of 2x plus 1. Square both sides. 9 equals 2x plus 1. Subtract the 1. 8 equals 2x divided by 2. X equals 4. Let's test it. 2 equals 5 plus the square root of 9. 2 does not equal 8, so that is extraneous. And last but not least, square both sides. 8x plus 1 equals 25. 8x, bless you, equals 24 because I subtracted the 1. Divide by 8. X equals 3. 8 times 3 is 24. 24 plus 1 is 25. Square root of 25 is 5, which equals 5. It works. Guys, thank you so much, everyone out there in the internet. Thank you so much. I hope you have learned a lot. Study, practice. We have last few quizzes and tests. Have a great day. Thank you.